A document is a written, drawn, presented, or memorialized representation of thought. Naturally, images of documents are common and are constantly present in our daily life. Unlike images that capture physical objects, document images contain text, sometimes in a significant amount, and locally editing the vast textual content may involve tedious manual repetitions. The problem of efficiently propagating a sparse set of user edits has been previously addressed in the context of color and tonal editing. To propagate the user edits, previous works are guided by the principle that regions of similar appearance should receive similar edits. In our work, we are interested in propagating textual edits in document images. Textual regions contain latent semantics that must be accounted for in defining their intra-affinity. Therefore, unlike the traditional setting where the affinity between a pair of elements is measured in terms of appearance and position only, we present a multimodal embedding technique that learns the semantic affinities among textual regions and consequently enables propagating edit operations among words that are close by in a latent embedding space. To learn the semantic affinities, we take an unsupervised approach. Given an input image, we first extract the words using an off-the-shelf OCR framework. As isolated words are not sufficient to effectively analyze natural language, we augment the words with a contextual notion by grouping horizontally close by words and associating a contextual line to each extracted word. For each word and contextual line, we extract multimodal features that encode visual style, semantic content, and geometric attributes. These multimodal features are then concatenated for each word and for its associated contextual line, yielding a high-dimensional representation for each word in the image. The key technical contribution of our work is an optimization scheme which learns a weighted nonlinear combination of the initial high-dimensional representation. We leverage reliable pairwise connection in the data and formulate these reliable connections as masking constraints, and then use a Siamese network to pull the representations closer together, yielding an affinity space where a pair of words with high affinity are located close by. Finally, we group the optimized representations to obtain clusters of highly similar words. For each word the user selects to edit, we propagate the edit onto all the words within its cluster. In our editing framework, the optimized affinity space can be refined with just a few user-drawn scribbles that describe words that should or should not be linked together, outputting a grouping result which better suits the user's preferences. We demonstrate our textual edit propagation approach in the context of several novel applications, spanning style, content, and geometry editing operations. We demonstrate two different style manipulation modes. One mode allows users to emphasize textual regions in the image. The other allows users to manipulate stylistic parameters such as font type or color. The user can also select to propagate edits that modify the semantic content within the image. For example, we can propagate mathematical operations on words that depict numbers or dates. We also demonstrate propagation of edit operations that modify the document structure. We can, for instance, indent the selected text by a certain margin. We can also remove textual regions in the image and bring them back interactively as the user hovers his mouse over a nearby textual region. This allows for a dynamic image, where the user can digest the content in a gradual manner versus a still image where the content appears all at once. For more details, please see the paper. Thank you.